principle, an electron is confined to a region of width of 5.00 times 10 in exponent minus 11 meter, which is its uncertainty in position delta x. Estimate the minimum uncertainty in its momentum. So now we already know the formula. The product of the uncertainty position delta x and the uncertainty momentum delta p is greater or equal to the Planck constant h. But now this equation we want to solve for the uncertainty momentum, so everything we are dividing by the uncertainty position delta x, both sides with the delta x. And delta x with delta x can be simplified. And this inequality, it happens to be delta p is greater or equal to the h divided by delta x. And now delta p is greater or equal. Now we want to find those, to plug in the numerical values. But first of all, let's find out what is the h. So h, the Planck constant, is equal with 6.626 times 10 in the minus 34 joule times second. Now we are going here to plug, instead of the h, of course we are going to plug this constant, Planck constant, which happens to be 6.626 times 10 in the minus 34. But instead of the joule, joule we know is the units Newton times meter, but Newton is a kilogram times meter per second square. And let me plug here those units, kilogram, meter per square. But we already know here is a second times second. And what do we have else? Delta x is a 5.00. 5.00 times 10 in minus 11 meter. So those are the units. But first of all, let's see what we can simplify here. What we can simplify the second square with the second goes away. Meter with the meter, here is meter square. With one square here goes, so remains just 1 meter, remains here. And this is a delta p. And now what do we have? A delta p is a greater or equal. Now we can calculate everything here. But what's happening here? First of all, let's go and let's divide 6.626 divided by 5. If we are taking this in consideration here, so let's divide 6.26. It's not correct, because it's a 6.626 divided by 5 is 1.325, but let me say this is equal to 1.33 because we are estimated in 2 decimal points in 100. And now here minus 34 minus 11 is going to be times 10 in minus 4 minus 1 is 3, and 3 minus 1 is 2, 23 kilogram meter per second. So those are so the uncertainty momentum is going to be greater or equal with 1.33 times 10 in minus 23 kilogram meter per second.